500 list would be more willing and to invest in those machines as well. Just to create a psychological motivation also for universities to invest in these sorts of systems.
UCLA has a question. I was going through your slides and I was wondering how much power requirement are we looking at for this kind of huge database data centers?
Well, so currently, basically the fundamental lower limit, lower bound is given by the disk drives. Okay, and there is, of course, the disk drives are getting a little better. So typically now a 2 terabyte drive typically is running on 6 or 7 watts of power. So I was able to, I think right now we are somewhere at around 20 kilowatts per petabyte, including the servers. So that's not an unreasonable figure of merit. Of course, as solid-state disks are becoming cheaper and larger capacity, then this will change, but not by an order of magnitude, by a factor of a few. Then we might start thinking also about not necessarily keeping all the disks constantly spinning. So be more aggressive about these strategies and understand the impact of this. But I think on the storage end, so basically the 20 kilowatts per petabyte maybe can be lowered by another factor of 2 with a bit of extra effort.
You have a question from Indiana?
I was just wondering, like, if you start like building all the reliability, the redundancy, and think about the coherency of the data sets and everything, like, if we start reinventing all of it, I was wondering, like, with the communication, like links, optical fibers, and the technology moving forward, like, is this like more like a paradigm of stepping back and push forward a lot, or like, I was wondering, like, what would be the trade-off between like improving the current communication base and the storage-based infrastructure versus rebuilding over? How can that be looked at?
Sorry, could you maybe come just a little bit closer to the microphone?
Oh, sorry.
So I'm getting a lot of room reverberation.
I was just wondering, like, for this newer infrastructures, again, like lots of the redundancies, and so the data doesn't get lost in the transits, and so lots of things built from scratch right now. Whereas like the existing infrastructure, like the communication, the fiber technologies and the storage have been also moving forward. So I was wondering what would be the trade-off on this, like stepping back to march ahead, like how can that be compared again?
I still did not get your last sentence. And,
sorry, like my basic question is, like, how much of an investment will be in building lots of reliability and fault tolerance and the coherency of these data sets to be consistencies versus like fixing the lots of or improving the current communication channels and the storage? Will that be like, can we do some heuristic comparison, like?
Well, so my take is that yes, it's a substantial investment. I believe also that a lot of this has already been done, for example, by Google and Microsoft. So they already built an infrastructure. It's kind of a pity that a lot of this is right now not open source or publicly shared or known. So in a way, I think they are right now way ahead of the academic community, because they put an enormous investment in creating basically this redundant and massively parallel architecture where also the I/O bandwidth and the network bandwidth in the texture is quite comparable on every one of the servers. So the data locality matters a lot less than even on the machines that we build. So I hope that eventually the results of some of this research will also come out into the open. There is also the exascale movement now starting at DOE. Essentially, without solving these problems, we will not be able to cross over to the exascale. So in a sense, we live in interesting times. So I think this is a very hot topic for, I think, academic research, and I think there are a lot of fabulously interesting challenges in understanding the kind of re-architecting and re-engineer all the data movement across such systems, and understand how can we do this through the existing open source frameworks.
EVL has a question.
With regard to 5-year or upcoming trends in scientific data sets, do you see university libraries as playing an important role in data curation, or maybe even taking a leading role in this field?
Well, I surely hope that they do. Okay, and the main reason, my main reason for saying this is that we need an organization that has a long history. And university libraries are probably some of the oldest organizational entities on the planet, probably besides the Catholic Church. So they certainly, university libraries have existed for hundreds of years, and right now they are in search of their new mission, with all the electronic publications taking over. So the university libraries need to reinvent themselves. And traditionally, these libraries have been the curators of knowledge. So, in Trinity College in Cambridge, they still have Newton's original notebooks. And such a way, I think it's not unreasonable to believe that in this new world, the university libraries, which hopefully will exist again for hundreds of years more, then they step into this vacuum that exists right now, and basically spearhead the effort of curating these data sets, which I think is it's an unknown challenge, an unsolved challenge today. So how can we essentially keep curating with when the technologies, underlying storage technologies and data representation technologies are changing essentially again every couple of years? So we have to have people. This is not a computing problem. This is not even a storage problem. I think it is really a knowledge management, information management problem. And I think today, the librarians are best suited, I think, to step into this, working together with the domain scientists. And I think it was a distributed organization of many university libraries who all chip in their special expertise. We can create something that is reasonably fault tolerant and doesn't have a single point of failure.
Can you predict the importance of a general purpose multi-core system versus a GPU system? And also, is there effective tools or communication libraries for threads in GPU systems to support complex data mining algorithms?
Yeah, well, so right now, kind of the current architecture of the chips makes the programming reasonably complicated. But I think, from taking several steps back, the multi-core / GPU, some combination thereof, is totally inevitable. If for nothing else, it's the power perspective. So they are essentially capable of performing the same computations at a fraction of the power that you would need with the ordinary architectures. So in that sense, we absolutely will be forced to move to the GPUs and multi-cores. And I think, yes, the software technologies essentially for the programming has to get much, much better. But also we have to figure out how do we port our applications when the number of threads is not 10,000 like on today's high-end graphics cards, but it's 1 million.
Minnesota has a question.
So I'm thinking about data that has a lifetime, for example, sensors that collect data for weather prediction. Now, does that kind of data fit into the kind of data-intensive scientific computations that we are talking about? And a follow-up question on that is, does data have a lifetime at all?
Oh, absolutely. And data also has a value, and not all data is equal, first of all. So there is, and this is again a question related to the curation problem. So how do we assess how do we deal with the data curation? How do we determine which bits of data need to be saved kind of more carefully for the long run, and which pieces of the data can be discarded? Especially when we have data streams, then at that point we have given up in storing every bit of the data. So I think this needs to be approached again in a systematic way, and we are just scratching the surface today. So if I was a graduate student, this would be actually a very interesting thing to work on today.
We have a second question as well.
Hi, as a physician looking at large data centers, I see the virtual reality of a computerized patient medical record. What privacy issues do you think need to be scaled into data centers to make them work?
Well, so the privacy issue is something very, very complex and complicated. So I think that in a way, if we do the computations on top of the data, and certainly, for example, some of the identifiers are already masked of this analysis, that essentially will make probably the work, the job of the security people a little bit easier. But nevertheless, I mean, so at least if we don't have to move the data physically to the clients where the computations are done, because then we have to worry all the encryptions along the way and so on. But I'm not really an expert in this part of it. So.
This is Jeffrey again. You mentioned Microsoft and Google being pioneers in this field. If you look at their problem, is it similar in sort of the balance between computing and data, or I/O and flops, to say your data or other scientific data, or is it in a different regime?
Well, I think this I/O to flops is kind of a continuum. So on one end are these machines that, for example, I was trying to build, and I think eBay has a very similar system. The other extremes are the scientific supercomputers. A lot of these applications with the search engines are probably in between, because if you, for example, want to compute all the feature vectors, then you probably spend a lot more cycles per byte of data. When you do the searches, then you actually want to spend relatively few cycles per byte of data. So there is a continuum where I see the biggest differences in today, kind of in the Google and Microsoft cloud world and scientific computing, that today still the I/O, the proper I/O they get for a virtual instance is limited to 15-20 megabytes. 10-20 megabytes per second, which is not enough for substantial scientific computing to move it across. And also, it's very difficult to run a tightly coupled application. So if your problem is brutally parallel and you can chunk it into a million parallel threads without too much communication, it works fine. But also the MapReduce and Hadoop, kind of the weak point is the reduced step. Then you have to redistribute the data.
Are there any more questions? So I would like to thank Alex for his wonderful talk and entertaining our questions, and I'd like him to go back to his conference, and we will have a break now and resume in roughly an hour's time. Thank you very much.
Yeah, thanks. And once again, I apologize for the call.